Alright, hi guys, it's Miss Scott here to talk to you today about how to use Newton's laws, first and second, to solve problems much like this, which you are going to see in the very near future. So, let's start off by reading our problem and seeing what we have and seeing what we want to solve for. So I have a picture, an object is suspended from two wires as shown here. So we have it hanging, say this is your ceiling, and you have kind of a wire at a funny angle and then one parallel to the floor. Find the force of tens 2, and I should have labeled that. This is tens 2, this parallel one, and tension 1 is that one at a funny angle. So, you might be looking at this and saying, Miss Scott, there's one number there. There's actually two numbers here. What do you want me to do with that? Well, you actually have a lot more here than just this one number. You can infer a lot of things, and sometimes that's what it takes. You have to look at what you are given, and there are things in the details that tell you what you have. First off, this object is suspended from these two wires, and I guess I probably would have stated this in a test, but this thing's not accelerating. It's not moving anywhere. It's at rest, and we know if something is at rest and or moving at a constant velocity, all forces must be balanced. So this tension, this force is pulling kind of that way towards the wall. I know whatever this is equal to however much of this wire is pulling this way. And you might say, that's great. You don't have either of those. Yes, you do. You can guess, you can figure out what this is, because you know how much is pulling up. And again, you're saying, no you don't, and I'm telling you, yes you do. You are told that this thing is 3 kilograms. That's its mass. Its mass is 3 kilograms. I'm going to write that down. I know mass can be used to find weight. Weight is a force. Weight is the force of gravity acting down on an object, pulling it towards the center of the earth. So I would draw that right there, Fg. You know the formula for Fg. Fg equals m times g, which would be 3 kilograms. And in my class, g is 9.8 meters per second squared. In your class, it might be 10. That's okay. Nobody's wrong. It's okay. So 3 times 9.8, which is 9.8. So I know my Fg is 29.4 newtons. 29.4 newtons is pulling this thing down. But because this thing's at rest, I know that the vertical component of this force has to also be 29.4. If it wasn't, it would be accelerating down or up. And it's not. So I'm going to plug that in, 29.4 newtons. That's the vertical of tension 1. That was weird. Alright. And again, you might be saying, well, you still don't have the horizontal, Miss Scott. What are you going to do? And I'm going to tell you, I'm going to find it. Because you have enough information. Now, you have, the reason I drew this here instead of here. Yes, technically, it looks like that. All I did is I moved this from here to here. And that makes a pretty right triangle, which I can use using trig. So I'm told this wire is at a 50 degrees above the horizon. I know what the opposite side is. I don't have the hypotenuse. I don't have the adjacent. So if you want to go through your trig function, sine uses the opposite. Whoops. Sine uses the opposite in the hypotenuse. Cosine uses the adjacent and hypotenuse. And tangent uses the opposite and the adjacent. So which one of those do I need to pick? I need to pick the one. I can't be this one because I don't have that. I have this, but I don't want to find hypotenuse, so I'm not going to use sine. I don't have adjacent, and I don't have hypotenuse. I definitely can't use cosine. But I have tangent, I have the opposite, and I'm looking for the adjacent. So I'm going to use that. The tangent of the angle equals the opposite over the adjacent. The tangent of 50 degrees is equal to the opposite over the adjacent. 29.4 over the adjacent. So, we had to solve for a. We had to get a by itself. So I'm going to move a to this side, multiply it. I see I'm going to rearrange that. It turns into a equals 29.4 over the tangent of 50. And you might be saying, well, why didn't you take 29.4 and divide it by, or take tangent 50 over 29.4? That's why I moved the a first. So you ended up with tan 50 times a equals 29.4. Now it's clear what you had to do with that tangent 50. You divide it, put it in the denominator, but that's another story. Alright, so let's go ahead and solve for that. I'm going to do, well, first I'm going to check the mode of my calculator. My calculator is in degree mode. Please make sure if you're using trig that it's in degrees. If you get a wacky negative number for an angle between 0 and 90, chances are you're in radian mode. Fix it. So, 29.4 over the tangent of 50. That gives me a number 24. I'm going to say 24.7. So on my adjacent side, this side is 24.7 newtons. I was asked, what is the tension of 2? This wire is pulling 24.7 newtons to the left. So your answer, because this thing's at rest, and again, let me stress that this thing's at rest, you know every force has to be balanced out by its counterpart. You're going to end up with a force on tension 2 is also going to be 24.7 newtons. I can't turn this thing off. Okay, maybe I'll keep going. So again, the only way I was able to do this was knowing that all forces are balanced. It's Newton's first law. That's the only way I can figure this problem out, using only these two pieces of information. At 3 kilograms and 50 degrees. All forces are balanced when things are at rest or moving at a constant velocity. Seriously, why can't I?